All right, guys, welcome back to another lesson for Math 8, lesson 106, reviewing the effects of scaling on volume. Sorry, it's a little bit dark over there because I have the light mostly over here. And so today's lesson is actually pretty easy because it's a review. We already know how to do this, and so there's only one example. And so let's actually get into it. By the way, please be checking Google Classroom. I'm going to make really important announcements about tests. I know that I would tell you when it would happen, but because it got extended and because of what's been happening, I'm going to give you 3 tests. One before spring break, one after spring break, and the one after the week after spring break. And so if that continues to happen, what's going to happen is that you will have to expect 1 test per week, which is pretty much what we did in class. And so, yes, so I'm going to have to give you a time limit. I'm sorry. It's not like it's going to be homework from one day to another. I'm going to do it so that I put it into the classroom and then you have to submit it back into the classroom. And I'm going to put the instructions up there in Google Classroom so you have to look at it. Now, it is not my fault if you guys are not watching the videos or following in the Google Classroom. That means like you're quote unquote absent, but there's no excuse absences anymore. I mean, you guys can't take days off. That's what we're doing spring break, okay? This is not spring break, this is still class. So this is one of the reasons we have to do the videos, and this is one of the reasons you have to keep on contacting me in Classroom, because I know that I put a lot of messages throughout the day in Google Classroom. So you better be active there too. All right, let's get into the lesson. All right, the one and only example we have here, they say that we have like a brick that it's 3 pounds and the bigger brick is 1.5 times its measures in the ratio. So the scale factor is 1.5. So if we understand scale factor, we know that the scale factor is going to be 1 to 1.5, right? So this goes for the sides, the length, the width, and for the perimeter of the bases and of the faces, right? So that has to do with the sides. Let's call it sides. Then we have the area of the surface areas, right? It's going to be 1 squared to 1.5 squared. Well, 15 squared, you guys should know that, is 1 squared to 2.25. Not 1 squared, but 1 to 2.25. And then we have volume. And volume has to be cubed. So it's 1 cubed to 1.5 cubed. Well, I know what 2.25, that it's going to be 2.25, but then I have to do 2.25 times 1.5. So 5 times 5 is 25, and the 2 goes up. 5 times 2 is 10, plus 2 is 12, and then 1 goes up. 2 times 5 is 10, plus 1 is 11. And then a 0, and then 1 and 5 is 5, 2, 2. Right, so we're going to have 5, 7, 3, 3. How many decimal numbers? 3 decimal numbers. So it'd be 3.375. It will be 3.375 times bigger. All right, so that's what the volume would be. The volume, it's going to be 3.375 times bigger, but that's not the end of the question, because the question says, the larger brick has a 1.5 times length, width, and height of the small brick. What is the ratio of the volume of the larger brick to the smaller brick? I already found the ratio of the volume, which is 1 to 3.375, as you can see there. So the volume is going to be, the ratio is 1 to 3.375. And then the second part of the question says, if the large and small bricks are made of the same mixed materials, what is the weight of the larger brick? Well, this is 3 pounds for the smaller brick. How much will it be for the larger brick? Yeah, we have to use 1.5 cubed times 3. So what we're going to do is we're going to have to use 3.375 times 3. And that's going to be 5 times 3 is 15, and a 1 goes up. 7 times 3 is 21 plus 1 is 22, and a 2 goes up. 3 times 3 is 9 plus 2 is 11, and a 1 goes up. 3 times 3 is 9 plus 1 is 10. It's going to be 10.125 pounds. So the bigger brick is 10.125 pounds. Am I worried about you finding these numbers? A little bit, but I'm not as worried as you understanding that the sides, anything one-dimensional is going to be a 1 to whatever the scale factor is. But the area has to be squared. So 1 squared to 1.5 squared, and the volume has to be cubed because the volume is cubed. And that's pretty much it for the lesson. All right. So I'm going to leave it there for today, and then I'll see you tomorrow for more math. Hooray, math!